Hi everybody, in this lesson we're going to talk about graphs of the sine and cosine functions. We're going to look at amplitude and period for both sine and cosine, so let's get started. First of all, you need to understand what a periodic graph is, or a periodic function. You can see how on this heartbeat graph the heartbeat repeats every so often. So that's what periodic means. It means that the same shape occurs over and over. A periodic function is one that repeats. The period is the length along the x-axis from the beginning of a cycle to the beginning of the next cycle. Now let's look at the sine function, or f of x equals sine of x. And what we're going to do is just plug in some x values here and see what comes out for the y values. So, if x is 0 degrees, we know the sine of 0 is 0. And so we put a dot on our graph at x equals 0, y equals 0. And then if we do 90 degrees, we know the sine of 90 degrees is 1, because remember 90 degrees would be at the top of the circle. The point would be 0, 1, so the sine of 90 degrees is 1. And continuing on around the circle, 180 degrees is 0 right here. And then 270 degrees would be right here, so that sine is negative 1. And then back to 360 degrees, the sine again is 0. So take a look at this. If you think about just the y-coordinate, because remember sine equals the y-coordinate, then what's happening is the y-coordinate goes from 0 to 1 to 0 to negative 1 back to 0. If we go around the circle again, that same sequence is going to repeat. From 1 to 0 to negative 1 back to 0. So I'm going to do 4 more angles, and they're sine functions here. So let's go ahead and plot those last 4 points. Now, if we connect the dots, that is a sine graph. This shape is called a sinusoidal shape because it's the same as the sine function. And it's periodic. It repeats every so often. In fact, it repeats every 2 pi radians. So you see here the period is 2 pi because that's how many radians it takes to get from the beginning of a cycle to the beginning of a next cycle. Remember, it was 360 degrees to go through the whole sequence. Well, that's 2 pi radians. Now, the domain of the sine function is negative infinity to positive infinity. And domain, if you remember from algebra, domain is all of the x values that can be plugged into a function. So any angle can be plugged in, therefore the domain is negative infinity to positive infinity. The range, however, is all of the y values that we can get out of the function. And you can see that the lowest this graph ever goes is negative 1. And the highest it ever goes is positive 1. So the range of the sine function is from negative 1 to positive 1, with brackets because we actually do have sine values equal to negative 1 and positive 1. And here is the computer-generated sine graph from your textbook. So you can see it starts at 0. At pi over 2 radians, it goes up as high as 1. Then at pi radians, it's back down to 0, then down to negative 1, and back to 0 at 2 pi radians. Now, the graph is continuous over its entire domain. So again, domain is negative infinity to positive infinity. There is never an angle that we can't plug in and get the sine for. All the x-intercepts, notice the x-intercepts will be 1 pi, 2 pi, 3 pi, negative 1 pi, negative 2 pi. So the x-intercepts are in pi, where n is any integer. And the period, of course, is 2 pi radians because we have one complete cycle from 0 to 2 pi radians. Now, anytime we're asked to draw a sine graph, we actually do not want to have to generate that XY table every time. So let's just memorize the basic shape of the sine graph. Starting from the origin, it goes middle, then it goes up to the highest point, then back to the middle, then down to the lowest point, and then back to the middle. So we'll talk about the basic shape of the sine graph, and we'll always say middle high, middle low, middle. Now let's do the same thing for the cosine graph. We're going to pick out some x values, some angles to plug in, and we're going to generate their cosine values and graph those on this coordinate system. So if our angle is 0 degrees, we know that the cosine of 0 degrees is 1, because imagine right here at 0 degrees, the point on the unit circle would be 1, 0, so the cosine is 0. Now let's go to, oh, there's our dot on our graph. Now let's go to 90 degrees. We know at 90 degrees, the cosine value is 0, so that will put us here on our graph. And then let's go on to 180 degrees. At 180 degrees, the point on the circle is -1, 0, and therefore the cosine is -1. So let's put a dot at y equals -1. And then for 270 degrees, we'll go to the bottom of the circle, where the point is 0, -1. So remember, cosine is the first number, so the cosine of 270 is 0, so back here, y equals 0. And then 360 degrees, we're back to this part of the circle, the right side, where the point is 1, 0, so the cosine is 1 again. Now, think about it as what's happening to the x-coordinate as we go around the unit circle. The x-coordinate starts off at 1, then it goes to 0, then it goes to -1, then back to 0, then back to +1. That's what our graph is doing here. If we go around the circle again, we'll get the same pattern again, from 1 to 0 to -1 to 0 back to +1. So that's what you see here, and we'll plot those on our graph over here and connect the dots. And this is what a cosine graph looks like, and you can see it's very similar to the sine graph, except it hits the y-axis at a different spot. Otherwise the shape is the same. The domain is still -infinity to +infinity because every angle has a cosine. The range is still -1 to +1 because that's still the lowest y value and the highest y value. The period is still 2 pi radians, or we could say the period is 360 degrees because it takes 360 degrees to go from one wave to the same point on the next wave. Now let's take another look. Here's the textbook's cosine graph, and you can see it looks like mine, except that it's labeled, x-axis is labeled with radians instead of degrees. So again, it starts up high on the y-axis, then it goes down, then at pi radians it's at its lowest point, and then it goes back to 2 pi radians. We're back to a y value of 1. Notice that the graph is continuous over the entire domain, so like we said, every angle has a cosine value. Therefore, every angle can be plugged into the cosine function, and the domain is -infinity to +infinity. The x-intercepts are a little strange this time. Instead of in pi, the x-intercepts are at the half values of pi. Pi over 2, 3 pi over 2, 5 pi over 2, and then -1 pi over 2, -3 pi over 2. Those are our x-intercepts. So the way we have to write that is we only want the odd pi over 2's, right? Like you don't want to say n pi over 2 because what if n is 2? Then you're saying that pi is an x-intercept, but it's not. So you're trying to say that you want the odd pi over 2's. Well, to express an odd number, any odd number, in math what we do is we say, let n be an integer, then multiply it by 2. That forces it to be even. Then add 1. That forces it to be odd. An even number plus 1 is always going to be an odd number. So 2n plus 1 is just a way of saying an odd number times pi over 2. And the period again is 2 pi, because it takes 2 pi radians to get from the beginning of one cycle to the beginning of the next cycle. Now let's talk about the basic shape of the cosine graph. You can see that it starts high, then it goes to the middle, then down low, back to the middle, and back high. So high, middle, low, middle, high. Okay, now let's talk about amplitude. The amplitude is the height of the graph from the middle to the top. The distance from the middle to the top is the same as the distance from the middle to the bottom, of course. So in the function a sine of x, the amplitude is absolute value of a. Whatever number you see here, its positive version is the amplitude. We always consider amplitude to be positive even if a is negative. Now in this example, we want to graph y equals 2 sine x, and we want to compare that to the graph of sine x. So what I'm going to do is I've laid out 2 cycles worth of tick marks. So I'm going to draw the basic sine graph first, and we know that sine is middle, high, middle, low, middle. And we know that its range is from -1 to +1. So you can see here my highest value is +1, lowest value is y equals -1, and I'm going to repeat the pattern. So I have 2 cycles of my sine graph. I'm going to connect the dots. And now to graph 2 sine of x, what we'll do is take every y value from the sine x graph and multiply it by 2, and that will give us 2 sine of x. So for this one, 0 times 2 is still 0. For this one, the y value is 1. So 1 times 2 is 2. I'll put a dot here. And then we're back to 0. 2 times 0 is 0. Then for -1, 2 times -1 is going to be -2. That's down here. And then we're back to 0. So do the same thing again. And now if we connect the dots, you see the difference between the 2 sine x graph and the sine x graph. The 2 sine x graph has the same period because it still takes 360 degrees to go from 0, to go one whole cycle. So the period did not change, but look, the amplitude changed. The amplitude of the basic sine graph is 1. Remember, it's the distance from the middle to the top. And the amplitude of the 2 sine x graph is 2, because that's the distance from the middle to the top. It's 2. So amplitude is always the positive version of this number here, and the only thing it changes is the swing, or the height of the graph. Now here's the computer-generated version. There's just a little prettier than mine. So y equals sine x is here, and you can see that 2 sine x is here. So you can think of the amplitude, as a vertical stretch. When amplitude is greater than 1, it's going to make the y values exaggerate, or it's going to stretch the graph. If the a values were less than 1, let's say something like 0.5, then what would happen is the graph would shrink. So the a coefficient produces a vertical stretch or a vertical shrink. Now let's look at what happens if we change not the number in front, but the number in front of x. Not in front of the function, but in front of x. Here I'm going to take some x values. Let's take 0, pi over 4. These are just Angles, I've done every fourth of pi from 0 to 2 pi. Now, we want to plug into our sine function not the angle, but 2 times the angle. So here I've doubled every angle. So 2 times 0 is 0. 2 times pi over 4 is going to be pi over 2. 2 times pi over 2 is pi, and so forth. And we've doubled every angle. Then if we do the sine of these doubled angles, the sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, the sine of 3 pi over 2 is negative 1, and then the sine of 2 pi is 0. So you can see that as our angle that we're plugging in goes from 0 to 2 pi, we go through an entire cycle of the sine graph. But while our 2x has gone from 0 to 2 pi, our x value has only gone from 0 to pi. So one complete cycle is occurring between 0 and pi now, because what we're plugging into our sine function is double the angle. Let's do the same thing now, but for sine of 4x instead of sine of 2x. So here we've laid out every pi over 8 between 0 and pi, and we're doubling these angles again, or not doubling, but multiplying by 4. So you take 0 times 4 is 0. Pi over 8 times 4 is pi over 2. Pi over 4 times 4 is pi, and so on. Just multiply every angle by 4. You can see that the sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, and then when our 4x angle is 2 pi, we're back to the beginning. So this is one whole cycle for sine of 4x, but in the meantime, x has only gone from 0 to pi over 2. So now I have an entire period occurring between 0 and pi over 2. So one complete cycle occurs in pi over 2 units. So it says, in general, the graph of a function that is sine of bx or cosine of bx will have a period that is different from 2 pi. So here's the formula, and you need to memorize this. If b is not equal to 1, then the period is 2 pi over b. Now, it's true that even if b is 1, the period is still 2 pi over b, but we know that on the basic sine graph and basic cosine graph, period is 2 pi. So we only need the formula if b is not 1. So if b is not 1, period is 2 pi over b. Now, the way that we're going to use this is when we're asked to graph a function that has a bx argument, we're going to divide the x-axis into 4 equal segments. We'll have a starting mark, which for right now will be on the y-axis itself, and then we'll lay down 4 more tick marks. And these tick marks will represent the interval from 0 to 2 pi over b. In other words, it represents one period of our graph. And then we're going to label the tick marks, and then one cycle of the graph will fit on these 5 marks. So we'll use the basic shape to plot the 5 points. Remember earlier I told you for the sine graph we said middle, high, middle, low, middle. That's what we'll use to graph these. They're very easy to graph once we get going. For example 2, we will graph y equals sine of 2x, and we'll compare that to the graph of y equals sine of x, just so you can see how they're different from each other. So let's start with y equals sine of 2x. First of all, I can see here that b equals 2, and I know that period is 2 pi over b, therefore period is 2 pi over 2. So let's simplify, and we see now that period equals pi. Okay, so when I lay down my 4 marks, 1, 2, see, well, not counting my starting one is on the y-axis, and then I go mark, 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 mark. So my 4th mark, that represents pi. which is the end of my first period. And I've gone ahead here and laid down 4 more marks to make a second period. Now if pi is the end of the first period, then I add another period to that. The end of the second period will be 2 pi. And now let's use the basic shape of the sine graph to put our dots here. The sine graph goes middle, high, middle, low, middle. And then the cycle will repeat, middle, high, middle, low, middle. And we can connect the dots. So this is the graph of sine of 2x. Notice that we get one complete period in between 0 and pi because the period is pi. Now let's do the same thing for y equals sine of x. We know that here b is 1, therefore the period is 2 pi. And so if we lay down our 4 marks, I need 4 marks between here, the starting place, and the ending place. So not counting the starting place is 1, and then we'll lay down 4 more marks. So to get them evenly spaced, I put them here. Now the sine graph still goes middle, high, middle, low, so that one will go right here, middle. And can you see that right there? That's where our sine graph is going to go. So look at the difference between sine of 2x and sine of x. You can see it's like sine of 2x is moving faster. It goes through 2 whole cycles in the same number of radians that the other one goes through 1 whole cycle. And here is the book picture of the same thing. They've labeled their tick marks. Well, see, from 0 to pi, you see we get 1 whole cycle of the blue graph. That one is sine of 2x. And from 0 to 2 pi, we get 1 whole cycle of the red one. That is sine of x. So we can do 2 of the blue graph in the same amount of radians that it takes to do 1 of the red graph. So it's like the b number is either a horizontal shrink, like here the period is shrunk, it's like the graph is being pressed together, or if that's when b is greater than 1, it's like it's a shrink. When b is less than 1, it's like a horizontal stretch. So let's graph now y equals cosine of 2/3 x over 1 period. So b is 2/3. That means the period is 2 pi over 2/3. Or instead of saying 2 pi divided by 2/3, we could say 2 pi times 3/2. Remember to change a division to multiplication, we multiply by the reciprocal. And now you can see that your 2's will cancel, and your period equals 3 pi. So when I lay down my 4 marks here, of course the y-axis is my first mark, we don't count that one, and then we lay down 4 more marks. This last mark represents 3 pi. And this is a cosine graph, so my basic shape will go, well, the amplitude is 1, okay, because I don't have a coefficient in front of my cosine function. And the basic shape is going to go high, middle, low, middle, high. High, middle, low, middle, high. And connect the dots. And that is one complete cycle of the cosine of 2/3 x. Here's the textbook graph of cosine 2/3 x. You can see that the amplitude is 1 because that's the coefficient of our cosine function. The period is 3 pi. We calculated that on the last screen, so you can see that it takes 3 pi radians to complete 1 cycle. Now I just want you to notice that b is less than 1, b is 2/3, and it takes more than 2 pi to cover 1 whole cycle, because remember if b is less than 1, it acts like a horizontal stretch. So it's like our graph has been pulled horizontally, or it's been stretched. Now I want to show you how to calculate these middle numbers on your tick marks. You don't always have to do this. Certainly you saw in the last graph we graphed it without actually doing this calculation, but I want to show you how they're getting these numbers in case on a multiple choice test you ever need to figure out these numbers. So the first one we will do is the middle one. What you do is, you know the starting place is 0 and you know the ending place is 3 pi. So you want to average 0 and 3 pi. So what I've done here is I've added them together and divided by 2. That's what an average is. And then 0 plus 3 pi, of course, is 3 pi. And the denominator is 2, so the middle is 3 pi over 2. Now, to get the first quarter number, we'll take 0 and 3 pi over 2 and average them. 0 plus 3 pi over 2, or the end plus the middle, and then divided by 2. So that's going to be 3 pi over 2 over 2. And what happens is, this denominator, this is like 3 pi over 2 times 1/2. In other words, your denominator, your 2's just end up collapsing on each other and making a 4. So that's 3 pi over 4. Now let's do this third quarter. Okay, so we'll want to average 3 pi over 2 and 3 pi to get this number. 3 pi over 2 plus 3 pi. Now, 3 pi is like 6 pi over 2. I need common denominators here. So I multiplied my 3 pi by 2 over 2, and 3 pi becomes 6 pi over 2. Now I add 3 pi over 2 plus 6 pi over 2, and I get 9 pi over 2, but it's all over 2. So 9 pi over 2 divided by 2 becomes 9 pi over 4, and that's where that number came from there. Now we have not seen a negative a yet, but when we're fixing to. So when a is negative, the graph of y equals a sine bx is a reflection across the x-axis of y equals a sine bx. Now basically what this means is it takes the whole graph and it does a vertical flip with it. So let's graph y equals negative 2 sine of 3x. And first we'll pick out the amplitude. Amplitude is 2. And b is 3. And of course we do have a vertical flip happening here because of this negative. Now let's use b to figure out the period. Period equals 2 pi over b. Therefore period is 2 pi over 3. So the next thing to do is to lay out our marks. Notice my starting place is my first one, and then I laid out 4 more marks. This end mark is going to be 2 pi over 3 because that's the end of the first period. Now, amplitude is 2, and the basic shape is sine, but it's been flipped upside down. So instead of middle, high, middle, low, middle, I have to go upside down. It's going to be middle, low, middle, high, middle. So middle, then low, all the way down to negative 2, then middle, then high, all the way up to positive 2, then back to the middle. There's your shape, and you just connect the dots. That is one cycle, or one period, of the graph of negative 2 sine of 3x. And we'll see the same graph, the textbook version, on the next page. There it is. And so theirs looks exactly like ours, except they have labeled the first quarter and the middle and the second quarter. So let's go ahead and see how they got these numbers. First of all, to get the middle, they'll have to average 0 plus 2 pi over 3. And so that's going to be 2 pi over 3 over 2, or in other words, that's 2 pi over 6. But your 2's cancel, it reduces, and you end up with pi over 3. so the middle is pi over 3. Now let's get the first quarter, so we'll have to average 0 and pi over 3. So 0 plus pi over 3 all over 2. Add them together, we get pi over 3 over 2, which is pi over 6. And for the third quarter, we'll average pi over 3 and 2 pi over 3. So pi over 3 plus 2 pi over 3 is going to give us 3 pi over 3, which is just pi, and then the denominator is still 2. So 3 pi over 3 reduces to pi, and the denominator stays the same. And so our third quarter number is pi over 2. Now, when we've had b so far, it's always been just a number. But if b is a multiple of pi, the x-intercepts of the graph are going to be rational numbers. Instead of counting the x-axis in pi's, we'll count it in whole numbers, which is easy enough. So let's take a look at one. Y equals negative 3 cosine of pi x, and we're going to graph that over one period. So let's see. The negative means that we're going to have a vertical flip. The 3 means that the amplitude is 3. And b is pi. That means period is 2 pi over b, or 2 pi over pi. That means that the period is 2. Well, nothing could be easier to graph. So when we lay out our 4 marks here, this one is 2. Remember that the 4th mark always represents the end of your period, so that one's 2. And now these others are going to be easy to label later on if we want to. Now, okay, so cosine would normally be high, middle, high, but it's upside down. So it's going to be low, middle, high, middle, low. It's upside down. And when we connect the dots, you can see. Okay, let's flip over and look at their answer, the book's answer. And it looks exactly the same shape. And you can see here that the end of the first cycle is at 2. And then it's easy to figure the middle is 1, because halfway between 0 and 2 we should have 1. Well, halfway between 0 and 1 we should have 1/2. Halfway between 1 and 2 we should have 1.5, or 3/2. And so that's the graph of negative 3 cosine pi x. Now for our last few examples, they're going to give us a graph, and we're going to have to work backwards to find the equation that matches that graph. And it's really not hard to do. We're just picking up clues here, kind of like Sherlock Holmes. So the first thing I'm going to notice is that this is a cosine graph that has been flipped over. It's upside down. Therefore, we do have a vertical flip. Therefore, A is negative. So I know I'm going to need a negative in front of my A. Now let's also notice the amplitude. It looks like amplitude is 2. Okay? And now let's get the period. I get one whole cycle in between 0 and 4 pi. Therefore, now that's not the period. Well, no, that is the period. I'm sorry, that's not B, is what I meant to say. So the period is 4 pi. That means we know that period is 2 pi over b. And so here, if we multiply both sides by b and divide both sides by 4 pi, it will say b equals 2 pi over 4 pi, or in other words, b equals 1/2. Alright, now that we have all the pieces, we can say negative a cosine of b times x. Or instead of writing 1/2 x, we can say x over 2. So negative 2 cosine of x over 2. Now I want to show you a kind of a shortcut. Not only can we calculate b the way I showed you here using the period formula, we can also just read b off of the graph, but you have to know where to look. If your graph starts at 0, you can go out to 2 pi and see how much of the graph can I see between 0 and 2 pi. It looks like half of a cycle between 0 and 2 pi. It only goes low, middle, high, and then we're at 2 pi. So that's only half a cycle, therefore b is 1/2. b is the number of cycles you can fit between 0 and 2 pi. Alright, now determine an equation of the form y equals a cosine bx or y equals a sine bx, where b is positive, for the given graph. Okay, first of all, I look at it and I can see that its basic shape is a cosine and its amplitude is 3. Alright, now, in between 0 and 2 pi, it looks like half of a cosine wave. So we can say b equals 1/2. Now that I know a and the basic shape and b, I can say y equals 3 times the cosine of 1/2 x, or in other words, 3 cosine x over 2. Here's another one. Determine an equation of the form y equals a cosine bx or y equals a sine bx, where b is positive. So let's just look and see what clues we can gather. First of all, I see that the basic shape is middle, high, middle, low, middle. Now that's the basic sine shape. So basic shape is going to be sine. Amplitude seems to be 3. And now let's see how many cycles we can fit between 0 and 2 pi. Now a cycle is middle, high, middle, low, middle. That's one cycle. And then here's 2 cycles. Here's 3 cycles. Here's 4 cycles. So it looks like at 2 pi we're at the end of the 4th cycle. That means b is 4. And therefore our equation is y equals 3 sine of 4x. It's always a shape bx. Now, suppose that you had not been able to see all the way out to 2 pi. If you can only see part of the graph, you can't really count cycles the way we did. So you might have to go back and use the period formula, and I'll show you how to do that. We can see right here one whole cycle in between 0 and pi over 2. So that means the period is pi over 2. And so we're going to plug that into our period formula. Period equals 2 pi over b. I'll multiply both sides by b and divide both sides by pi over 2. Now when I do that, this 2 is going to come up to the top and this pi is going to go down to the bottom. And the pi's cancel and we're left with 2 times 2, which is 4. So we already knew b was 4, but if you can't see all the way out to 2 pi, you might not be able to count, and I wanted you to see how to use the formula when you have to. Let's do one more together. This one says determine an equation of the form a cosine bx or a sine bx, where b is positive. So it looks like our graph is low, middle, high, middle, low. So I'm going to say that this is a cosine graph that's been turned upside down. So I say a vertical flip means a is negative and the amplitude is 3 and the basic shape is a cosine. Now I can see all the way out to 2 pi, so let's just count cycles. That's 1 cycle, 2 cycles, 3, 4. So it looks like b is 4 again. And so now they tell you right here how to put it together. A is 3, well it's really negative 3. A is negative 3 and then cosine of 4x. So y equals negative 3 cosine 4x.